Numberphile, Attack on Reason. This video by Numberphile, entitled Astounding 1 plus 2 plus 3 plus 4 plus 5 equals minus 1/12, is an attack on reason and fraud. You might wonder why a channel called Malayan English is doing a commentary video on a video about mathematics, especially when there's two excellent videos that reviewed the mathematics of why Numberphile's video is wrong by Mathologger. These videos also attempt to explain what it was the Numberphile video was trying to say. URLs are in the show notes. But I believe Mathologger is missing a broader point, the philosophical point that this was an attack on reason, particularly an attack on your ability to reason with respect to mathematics. This kind of attack on reason is called mathematical Platonism. As I've explained elsewhere, any attack on reason is an attack on freedom. Political freedom is built on reason. Mathematics and physics are often considered the pinnacle of reason, and by attacking the fundamental foundations of your understanding of mathematics, the goal is to get you to conform, shut up and conform. This Numberphile video is an expensive production, and the people in the video are high-level physicists and mathematicians, so I don't believe these mistakes can be written off as innocent error. I think these were purposeful mistakes and therefore fraud. Part of the fraud, as we'll see, is the fact that they play fast and loose with definitions, which is not something you would expect from people who are supposedly trained in mathematics and physics. But let's look at this video together so I can dissect it and show you some of the mistakes and some of the fraud that's going on in the Numberphile video.
I'm just going to write down a little sum, and we're just going to see what answer it gives. 1 plus 2 plus 3 plus 4 plus and I include all the natural numbers, so all the way up to infinity. The answer to this sum is remarkably minus a 12th. It's amazing. I mean, I first saw this result when I started learning a bit of string theory.
What's remarkable is that this guy admits that this idea comes from his understanding of string theory. String theory is a hypothesis in physics that didn't come as a result of trying to explain an experimental observation. In fact, most of the predictions made by string theory are not empirically testable at all, which means that the whole string theory idea is mathematical Platonism run amok.
And what's even more bizarre is that this result is used in many areas of physics.
This is a very well-known string theory textbook by Joe Polchinski. As you can see, sort of quite early on, page 22, we have this statement here, which is that the sum of all, this is basically saying the sum of all the integers, or the natural numbers, all the way up to infinity, is minus a 12. All right, so we're going to plus 1, minus 1, and so on. That's the first sum I want to look at in principle. The second sum I'm going to look at is 1 minus 2 plus 3 minus 4 and so on. Carry on in that process all the way up. And the third one is of course going to be our one that we're really interested in, which is 1 plus 2 plus 3 plus 4 and so on. So we're going to evaluate all these three different sums. Now the first one is really easy to evaluate. We need to attach a number. Now clearly, what is the answer to this? Now you stop this at any point. Okay, if you stop it at an odd point, you're going to get the answer 1. If you stop it at an even point, you'll get the answer 0. Clearly, that's obvious, right? So what number are we going to attach to this infinite sum?
This is the first indication that we have something in this video that is fraudulent. The guy says, what number do we attach to this sum? It's the sum of an infinite series. When you're talking about sums, you don't just attach a number to it. You find the answer if there is one. That's real math, as shown in this Mathologger video clip.
Why don't they work? Well, let's have a look at the first one here. Partial sums. We need partial sums. So first partial sum is 1. 1 minus 1 is 0. Plus 1 is 1, minus 1 is 0, and so on. So 1, 0, 1, 0, 1, 0. That doesn't converge to anything. That doesn't have a limit. So it's, you know, it doesn't have a sum in the usual sense.
We stop at an odd or an even point. Well, we don't know. So we take the average of the two. So the answer's a half. There are other ways to prove that this sum is a half, by the way, which we can do if you want. But
No, there'll be a link. There'll be a link there because we've done it before.
Okay, good.
So you'll see the link there.
Okay, so this is a half, but I think intuitively that's the easiest way to see it, that you either get 0 or 1, and therefore you just take the average.
So this is an infinite sum, which is divergent and bounces between 1 and 0 as its partial sums. He just waves his hand and says, we'll just take the average, 1/2. 1/2 is never the value of this sum, or any of its partial sums, and he gives no justification for this bullshit.
So this is the natural number to attach to this sum. But once we know this, we're laughing, okay? Because from this, we can achieve everything that we want to achieve. The next step is to find out what this sum is. So what I'm going to do is, I'm going to take 2 copies of this S2, okay? So I'm going to add it to itself. So 2 times S2 is equal to, well, let me just write it out. So I'm going to write it out twice. 1 minus 2 plus 3 minus 4, so on. And then I'm going to add to it itself, but I'm going to shift it along a little bit. So that's plus 1 minus 2 plus 3 minus 4 and so on. Okay, I've just taken 2 copies and added them together. But I've done it in a particularly nice way, in that I just push this one along slightly on the bottom. So now you see what you get. You take this one and this and this, and I get 1. So 1 plus nothing is 1. Minus 2 plus 1 is minus 1. 3 minus 2 is 1. Minus 4 plus 3 is minus 1, and so on. And I'm going to keep getting this pattern. So hang on a minute, I've just got back the sum that I started with, which I know the answer to. So half. Okay? So therefore I know this sum now. So I just divide through by this 2 and I get 1/4. So now I know that this...
You'll notice if he just did the partial sum of S2, he'd get 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4. In other words, I'd say, given his logic on the sum S1, average is 0. So S2 should be 0.
This sum, this second sum, with some where the signs alternate, is actually equal to 1/4. So this is my second remarkable.
I like this little trick of sliding S2 over by 1 position and adding it to the original. Let's do the same thing with S1. We'll have the new S1 on the bottom and the old S1 on top, which is 1 minus 1 plus 1 minus 1. The new S1, which is minus 1 plus 1 minus 1 plus 1. You'll notice that these are the exact same series. They both have an infinite number of 1s and an infinite number of minus 1s. If you add them together, you'll see that 2S1 is 0. That means that S1 is 0 instead of 1/2.
Now I have everything I need to prove this crazy minus a 12 thing, right? Okay, so let's do it. I'm going to take this one and I'm going to subtract this one. Okay, so I'm going to subtract S2 from S. Well, let's write them out again. Okay, so I'm going to write out S first, which is 1 plus 2 plus 3 plus 4 plus 5 and so on. Okay, and I'm going to subtract S2. So that's minus, okay, let me just put a bracket in now because I'm going to minus all of this. 1 minus 2 plus 3 minus 4 and so on. Okay, okay, 1 minus 1, what's that?
0.
0, yeah, exactly. So I get nothing from that bit. 2 minus minus 2 is 4. Okay, 3 minus 3, 0. 4 minus minus 4 is 8. And so on. And the next one, I'm going to get, from the 5s I get nothing, from the 6s I get 12, and so on, and it proceeds in that way. And now you can see we're almost there now, right? Because look what I've got here. I've got 4 plus 8 plus 12. If I take a factor of 4 out, it's 4 times 1 plus 2 plus 3, okay? It's my sum that I wanted. So now I've got a formula for my, so this is just 4 times S, which is my sum. So now I just solved this equation, right? Because I know what S2 is. So I have now the expression S minus, because I know what S2 is 1/4, is equal to 4S, Okay, I take s from either side, so I get minus a quarter is equal to 3s, which implies that s equals minus 12. So now do you believe me?
Here, Mathologger shows why these other series don't sum to anything. That's because they're divergent. Then he shows that what Numberphile is doing is just wrong, just bullshit. Well, he thinks that they made an innocent mistake. I think this was done on purpose, to undermine reason. It's a typical mathematical Platonist bullshit designed to undermine your ability to understand the world.
What about the second one? 1 minus 2 is minus 1, plus 3 is 2, minus 4 is minus 2, and so on. Also doesn't settle down. Forget about it. Last one, 1, 3, 6, 10 kind of explodes. All these series here on the left side are divergent. Again, as it was presented by Numberphile, all this is nonsense and worth 0 marks.
Or less.
Or less. This is not mathematics. Don't use it, otherwise you'll burn in mathematical hell.
Here, Mathologger explains that Numberphile plays fast and loose with definitions, which is the hallmark of a charlatan, and he explains what the proper definition of a sum of an infinite series is in math.
Pretty much every single statement made in this video is wrong. And by wrong, I mean wrong in capital letters. In particular, as anybody who knows any mathematics will confirm, 1 plus 2 plus 3, etc. sums to exactly what common sense suggests it should, namely plus infinity. So how did they get it so horribly wrong? And what did they really want to say? Well, they started out with some genuinely deep and amazing connection between 1 plus 2 plus 3, etc. and the number minus 1/12. It's critical to realize that in mathematics we have a precise definition which underpins the sum of an infinite series. Wherever you see infinite series, this definition and only this definition applies, unless there are some huge disclaimers to the contrary in flashing neon lights. All right? Now, the Numberphile guys did not include any such disclaimers, and so they too should get 0 marks for their effort.
Maybe give them minus 1/12.
Yeah, I think I can agree with that. Okay, what's this definition and what are the answers that will get you full marks on your maths exam? To evaluate the sum of an infinite series, you calculate the sequence of partial sums, just like the Numberphile guys did at the very beginning. Now, if the sequence of partial sums levels off to a finite number, that is, if the sequence converges, or if it explodes to plus infinity, or if it explodes to minus infinity, then this limit is the sum of the infinite series. If no such limit exists, then the infinite series does not have a sum.
Mathologger in this clip explains what Numberphile was really trying to do with respect to the sum S1 and S2. And we're taking the Cesaro sum, which I think is a misnomer. And if you're going to do the Cesaro sum, it should have a different nomenclature, so it cannot be confused with a regular sum. Again, this is something charlatans do. Purposely confuse two terms.
And there's actually a special name for this. The sum is Cesaro convergent, if that sort of thing happens, right? So if you've got a series, you first do the sequence of partial sums, and then you do the sequence of averages. If the sequence of averages converges to a number, then this number is called the Cesaro sum of the series that we're looking at. So the series is Cesaro convergent.
So I still have a problem with this Cesaro definition. The same one I pointed out before. If you rewrite the sum S1 as minus 1 plus 1 minus 1 plus 1, you get minus 1/2 as the Cesaro summation. That's a contradiction, and that's not what I consider good math. What is the meaning of the Cesaro sum? As far as I can see, there's no meaning behind the Cesaro sum. It's just mathematicians playing around. They try to claim that this is like imaginary numbers, but I don't think it's like imaginary numbers at all. First of all, they don't give it another symbology. Since you're not actually doing the same thing as summing, you're doing something different. With imaginary numbers, there did turn out to be a physical meaning. It was the phase of the signal.
And we can actually keep on going playing this game. So we had like the first sequence, that's us. Second sequence, that was my green alien friend who prefers this sort of summation. Then the blue alien friend who prefers the next one down. But then of course we can do more and more kind of averages. So the next one would be the average of the average of the average, another sequence. And these methods get more and more powerful. So you kind of go up and up and up and up and up, and you can sum more and more series. But what about this guy here? Will we ever be able to get to minus 1/12? Well, if you think about it, no, right? So we've got positive numbers here. We do partial sums, that's got to be positive numbers again. Average of positive numbers, again, positive numbers. Whatever you do here, you'll never get anything that will get into the minuses. Now here's something very, very, very important. Those first couple of summation methods that I talked about, they conceivably could really be replacements of the standard way of summing things on some planet. Now these more complicated summation methods, like Ramanujan's one, when you look at it, it's got integrals in it and it's got like sums in it and special numbers. They only work in special contexts. They work for special sorts of series. They're really, really useful there, but they could never, ever replace standard summation.
So there you have it. What Numberphile showed was wrong. Wrong with capital letters. And it was also deceitful. These people clearly know what the proper definition of a sum of an infinite series is, and they purposely ignored that. What they were really doing was a Cesaro summation, which they tried to say is useful. I looked up the uses for it. Supposedly it's useful in signal processing, but all it's used for is some sort of smoothing of the signal. It's an averaging. We have moving averages. There's nothing profound about the Cesaro average. It's not a good Cesaro sum. It's just mathematicians playing around with numbers. There's nothing wrong with it, but it's just mathematical Platonism, unless it's tied to reality. There's no profound meaning, and they try to claim that it's tied to string theory. String theory is not testable. It's not empirically based idea, and this is just fraud. Why is this fraud perpetrated? It's to undermine your ability to reason. And when you undermine people's confidence in math and science and reason, you undermine liberty. Long live freedom, damn it.